Right, so our last section for this week and our last section in chapter 1 is on solving or rewriting equations. Okay, so the goal here isn't always going to be to get a number for an answer, but maybe just to rearrange something and get a letter by itself. Okay, so it says an equation with two or more variables is called, and that's what you want to fill in on your notes. Okay, that's called a literal equation. Okay, so an equation that has two or more variables is called a literal equation.
You write two words in that space. Literal equation.
Okay, and when they ask us to rewrite it, okay, usually that means to get a variable by itself. Okay, if there's two variables in the equation, they have to tell us which one. Okay, so if an equation has an x and a y in it, maybe they'll say get x by itself. Or maybe they'll say get y by itself. Okay, but they have to tell us which letter they want alone. Okay, so as far as explaining like the steps and operations to do it, you guys already know the steps. All right? We already know how to solve equations, so we're going to use the same operations that we're already used to. Okay, so here's our first equation. And if you look at it, how many different letters are in that equation? Shannon? Two. Okay, now if we look at that equation, it says 2 equals 3x plus y. And it's asking me to get x by itself. Is x by itself on one side of the equal sign right now? No. Okay, my goal when I'm done is to have something like this. X equals, and all the other stuff on the other side. Okay, what's preventing the x from being by itself right now? Two things. Yep, Liam?
The number that it's hooked up to and the y.
And the y. Okay, both of those things are preventing x from being by itself.
So do you want them to solve for x in this one or solve for y?
We'll solve for x.
Because it says this said on the notes for y.
Oh, okay, yeah, I'm sorry. Change that to solve for x.
Just cross the x out.
Or just make it an x.
Yeah.
Yeah.
Make that y an x. Add a little leg to it.
I think the next,
Yeah, I mean.
yeah, I'll switch it. Yeah, I switched it. In the next one, I'm going to have you solve for y.
Yeah, so if you want, guys, you can write this one for an example 2 if you want. And so this will be example 2. So I said example 2 already says solve for x. So I'm just writing it for example 2.
All right. So what's that word that we use to remember the steps when we're solving an equation? Yep. Yeah. So we've got SAM. Right? In this problem, I don't see any parentheses. I don't see any distributive property, no like terms. So we're really just going to have to focus on those two steps. Okay. Did anybody see any adding or subtracting I can do to start to get x by itself? Yeah, let's start by subtracting y from each side. Okay, so I'm going to take my original problem, subtract y, and subtract y. Hey, Ashley, when I do positive y, take away y, what happens there?
Cancel out.
Yep, that cancels out. And on the left-hand side, I have 2 minus y. Can I combine a number with a letter? What do you think, Brett? No. Those aren't like terms. So how would I write this? What would I put down?
2 minus y.
Yeah, that's all you can do. Okay, 2 minus y. Okay, that's what's on the left. What's still on the right? Yeah, we still have the 3x. Okay, but now it's a little bit better because we're trying to get x by itself, and we got rid of one of the things that was there. Now I still got to get rid of this 3. Okay, so I've done addition and subtraction. Any multiplication or division that would help me to get rid of the 3? Yeah?
Divide the 3
All right, and where do I divide by 3?
on both sides.
All right, can you be even more specific and tell me exactly where? I don't understand what you mean by both sides.
You just divide 3 from x and
Divide 3x by what?
3.
Okay, so that's one of them.
And then you divide it on the other side.
How? What do I do?
Put 2 minus y over 3.
Okay, close. I want to do what you're saying. I want to divide this side by 3, but how do I do it? Emily?
Do you do it just by 2 over 3?
No, not just the 2. The 2 and the negative y. Okay, we divide both
Oh,
by 3. Okay, so when you divide by a number, we usually don't have this happen. Because when we get to the division step, we usually have something like this. Just a number on this side, just a number with a letter on this side. So there's only one thing here. We have 2 things. Okay, so when you divide, you have to divide everywhere. All right. So now, 3 divided by 3, that's gone. Can I reduce 2 divided by 3? What do you think, Bay?
No.
No, so we just leave it. Y divided by 3. I'll talk about that in a second. Equals, what's on the right-hand side now? Yeah, x. Okay, so we've got x by itself. The only thing that you might see written a little differently, the 2/3 is fine, but this y over 3. What number is in front of y all the time? Yeah, you're right. In this case, it's like a -1. So really, what fraction do I have right there? Negative what? Negative, think of it as just the number. Forget the letter for a second. Brett? Yeah, there's a -1/3 right here. Okay, so the other way you might see a problem like this written is like this. That's exactly the same as what you have up above. I would say most of the time, especially when we get to doing problems like with slope-intercept, they usually put the number in front of the letter, like that. Okay, this is not slope-intercept because we didn't solve for y. Okay, this is a little different. Okay, but any question on that? Okay, so don't forget, there's an invisible 1 there. So a lot of times they take the fraction and put it in front. What if I had something like x divided by 2? Can somebody tell me what that would be the same as if I rewrote it with the fraction in front? Josh? 1/2 times x. Yeah. Okay. What if I had 3x divided by 4? What would that be the same as?
3/4 x.
Yeah, 3/4 x. You're basically just taking this x and you're just moving it right in front of the fraction, or right after it, I guess. Okay? And if you forget, there's your invisible 1. So you just put the x right down in front. Okay? Does anybody want me to do one more like that? Just that seems all right? All right. Okay, so that's it. That's it. That's how you get x by itself. Okay, let's try one kind of like Mr. Roy did. Okay, you can write this one under where it says example 1 if you want, because it already says solve for y there.
And if you already put it in something, that first one we did for example 1, just put it for example 2, just make sure you change x to y.
So this one says solve the equation 3y plus 4x equals 9. Solve that for y. Okay, first, can anybody tell me what's preventing y from being by itself right now? Tell me everything that has to move away from the y. Yep, Liam, can you just give me one thing?
The 3 against 3.
Yep, the 3 that's against it, that's got to move away eventually. And what else? Brett?
4x.
The 4x. Okay, so both of those things have to go to the other side. Which one do we do first? Are we going to deal with the 3? Or are we going to deal with the 4x? And if you get stuck, think which operation you should do first, and then which one comes second. Yeah, Josh?
The 4x.
All right, we're going to deal with that 4x first. Can somebody else tell me how I deal with the 4x? How do I put it on the other side? How about Aiden? Think you can tell me how?
Minus 4x and the number
Yeah. Where are you going to minus the 4x from?
9
From the 9? Anywhere else?
and 4x.
Yeah, and the 4x. Yep. Okay. Sometimes I think what gets a little tricky is when you do addition and subtraction, you don't do it to every term. Okay. I know when I said you divide, you have to. But when you subtract, you just do it to one term on the left and one term on the right. Okay. Same with addition. Okay. And Sabrina, what's 4x minus 4x?
0.
That's 0. And Kaylee, what's on the left-hand side now? 3y. And how about Vanessa? What's on the right-hand side?
9 minus 4.
Okay, yeah. So we have 9 minus 4x. Anybody think of another way you can write that right-hand side? This is fine. This is correct. But there's another way you can do it. I think Mr. Roy showed you earlier. Yeah?
It's negative 4x plus 9.
Yes, negative 4x plus 9. These are the same thing. Okay, I just want to make sure, especially if it's a multiple choice question, that if you had this and I wrote that, you know they're the same. All right? Any questions on why those are the same? It's like you just switch the order. The 4 is still negative. The 9 is still positive. Okay? All right, and now my last step. Okay, one more step and we'll have y by itself. How about Derek? Can you tell me what my last step would be? Can you tell me what I have to get rid of? What's next to the y that I don't want there?
3.
Yeah, we want to get rid of that 3. So since the 3 is right next to the y, what operation do I have right here? 3 blank y, 3 times. What's the opposite of times? Yeah, we're going to divide. So we're going to divide by, help them out, what number? 3. And Shannon, how do I divide both sides by 3?
You put negative 4x over 3, and then you put negative 9 over 3. Or not negative 9, 9 over 3.
Okay. What else? One more thing. Sai, you see what else we got to do?
2y, 3 and
Yeah, put the 3 underneath that too. Okay, you have to do it in all 3 spots. Okay, and then that cancels out. Okay, anything on the right that we can clean up a little bit instead of leaving it the way that's written? Yeah, yeah.
9 divided by 3 is 3.
Yeah, sure, we can do 9 divided by 3 is 3. And if you want to leave this like this, that's fine. If you want to write it the way I showed you, that's fine too. Yeah, Brett, what were you going to say?
Could that be written out as -1 and 1/3 x?
That would be as a mixed number. We generally won't use mixed numbers here. Your 2 options are either, if it comes out nice, you just divide it, or if it's a fraction, we'll leave it as an improper fraction. But yes, it would be as a mixed number. So I'm going to write it like this. I'm going to write it as -4/3, and I put that x in front. And from what Mr. Roy said earlier, does anybody recognize what this is? If you don't know, that's okay, but you might recognize it. Josh?
Y equals NF.
Yeah. And a lot of times, if you want to take something like in the original problem, and you want to graph this, what we just did is how you would graph it. Now I can tell you the slope. I can tell you the y-intercept. If you don't remember, that's fine. Okay, but you're going to see this again later on. Okay, any questions on that one? All right. So, Mr. Roy, you want me to do this one, or you want to? All right. So, example 3, it says we own a rectangular lot. Okay, that's like your yard. Okay, it's the property you own. And it tells us that your yard is 500 feet deep. That's pretty deep. And we have an area of 100,000 square feet in our yard. Okay, you don't have to copy that down. It should already, it's already on your notes for you with the diagram. Right. So to pay for a new water system, okay, they charge us, or the city charges us $5.50 for every foot of what's called frontage. Okay, frontage is the amount of property you have up against the road. Okay, it doesn't matter how deep your property is. It just matters how much of your yard runs along the road. Okay, that's called the frontage. Okay, so they're going to ask us 2 things. Given the information, how much frontage do we have in our yard? And the second thing, once we know that, how much are they going to charge us to put in a new water system? Okay, so you have to find part A before you can do part B. Okay, what's maybe a really important word in that second sentence? It has an area of 100,000 square feet. What's a really key word in that sentence? A word that's going to tell us what formula we're probably going to use here. Yeah, Nini? Area. Okay, we have area, and we're talking about a rectangle. So I need to think about what is the formula for the area of a rectangle. Anybody remember that? Not something Mr. Roy and I went over, but something you should know. Area of a rectangle. Brett, can you help us out? You are the only person that knows this. You've got to save us.
A equals length times width.
A equals length times width. Perfect. Okay, that's your formula for area of a rectangle. Okay, now I'm going to look at that formula, and I'm going to see if I can figure out what I already know and what I don't know. Okay, A stands for area. If you read through the problem, did they tell me the area? What do you think? Yeah, Nini? Yeah, they tell me the area. What's the area? 100,000. Right there. I'm going to plug that in for the area in a second. Actually, you know what? Let's do it right now. So area 100,000. And that's equal to length times width. Okay, look at my yard. Do I know one of those two things? Either the length of the yard or the width of the yard? Trenton?
You don't know the width, you know the length is 500.
Yeah, I don't know the width, but yeah, I know the length is 500. Okay, so I'm going to fill in 500 for my length. And what did you say I don't know, Trenton?
The width.
I don't know the width. What do they call the width in this problem? They get at kind of a different word. Maybe we've never heard of this word before. Josh? Yeah, that's the frontage. Okay, that's the width of my rectangle. Okay, the yard that runs along the road. Okay, so if I can figure out what W is, that's the width of my yard. Okay, and I think I have enough information to do it. Okay, how would I solve this for W? About Eastleys? What do we have to do? What are we trying to get by itself? The width, yeah. What's preventing the width right now from being by itself? What's there that we don't want? Yeah, we don't want that 500 there. So how would you move 500 to the other side? Not sure which one?
No.
All right, what operation are you doing with the 500 and the W since they're right next to each other? Yeah, right now you're multiplying them. So we want to get rid of multiply. So what's the opposite of multiply? We divide. Yep. So we're going to divide each side by 500. And I'll use my calculator, and that'll tell me the width of my yard. Okay, so we have 100,000 divided by 500. So the width of my yard is 200 what? $200, 200 pay? Feet, yeah. Okay, so find the frontage. That's the width of the yard. Okay, 200 feet. All right, now part B. It says, how much are we going to be assessed to put in a new water system? Well, do they tell me anything up above that I haven't used that I'm going to use right now? Shannon?
The $5.50.
Yeah, what is that? I'm charged $5.50
Per foot
per foot.
of the lot frontage.
Yeah, we're charged $5.50 for every foot of frontage. Okay, Ariel, how many feet of frontage does this yard have? 200 feet. Yep. So this is 200. I'm charged $5.50 for every foot. So how do I figure out how much it's going to cost me to put in a water system? 200 feet of frontage, $5.50 per foot. Yeah, Aiden?
You're gonna take the 200 feet times 5.
Yep, take your 200 feet and multiply by how much it's going to cost per foot. $5.50. And that's it. Okay, so multiply those two together, and that'll tell us the cost to put in the new water system. So 200 times 5.50, it's going to cost $1,100 to have the city put in that water system for us. Okay, so that one's kind of similar to an MCAS question where you've got to figure out You gotta figure out the first part before you can figure out the second part. Okay, any questions on that? Okay, any formulas that you need to know that you might not be familiar with, we're going to give you. Okay, and in fact, I think on the next page, we've got a list of 3 formulas.
On the backside.
So yeah, flip over to the back of your notes. Okay, and the first formula there is for temperature. Okay, first one up at the top on the back of your notes.
And guys, if you want to write bigger so you can see it, you don't have to squeeze it in the box. You still have some room to the right of those boxes to write them in. You can squeeze it in the box if you want, but you don't have to.
The box is a little small, so you're going to write it next to it. So the first formula, it basically tells us how you change Celsius to Fahrenheit. Hey, and unfortunately, it's not really a nice number. That's why it's so hard to kind of do it in your head. You've got this 5/9. It's kind of weird. But you can work with it. We can use our calculator if we need to. Okay, but it says C equals 5/9, and then in parentheses, F minus 32. Okay, that's the formula that if you had a temperature in Fahrenheit, that's how you change it to Celsius. All right, so we use Fahrenheit here. Does anybody know where they use Celsius? Okay?
Almost everywhere but the United States.
Yeah, everywhere except here. Okay, we're kind of different. So Celsius is what's pretty much used everywhere else, and honestly, Celsius is simpler. 0, freezing; 100, boiling, easy. In Fahrenheit, it's all these weird numbers: 32, freezing; 212, boiling. It's just these random numbers. All right. Second formula we're going to look at is for what's called interest. Okay, so interest is money that either a bank pays you. Okay, that's a good thing, right? If you leave your money in a savings account, you might check it in a couple months, and you got like a few cents more because you made interest. Or the opposite, if you buy a house or you buy a car, you have to pay the bank for letting, it's like saying, thank you for letting me borrow money from you. And you pay them interest. Okay? So this is not actually the formula that a bank would use. This is called simple interest. The real formula is it's a little more complicated, but this one's it's pretty good. And it's simple. Simple interest. Okay? And it's the formula that says I equals PRT. Okay, if you can't read it.
Guys, we don't want to squeeze it in the box. You don't have to. You can write it to the right of it or to the left of it. You can write it bigger. If you want to put it in the box, that's fine too.
Okay, so this one has 4 variables in it. I is interest. I think this is already on your sheet. P is the principal. Okay, principal is how much money, in our case, are you investing? How much money did you put into a savings account? Okay, so that's the amount of money. R is your interest rate. Okay, so it might be like 2%, 4%, that's how much your interest rate is. And we'll talk about when we use the interest rate in a formula, we always have to do it as a decimal. So we'll talk about that. Okay, and T in this formula is your time, okay, in years. Okay, so if you had a house, if you borrowed money, is it a 30-year mortgage, 25-year mortgage? How many years is it? Okay, if it's a savings account, how many years did you leave your money in the savings account? Okay, so that's the second formula, and I think the test has definitely one on simple interest. And the last formula, I think you guys have already seen before. Okay, you guys remember doing distance, rate, and time? We talked about somebody famous in the Olympics. Who did we talk about? Usain Bolt. Yeah, we did distance equals rate times time. Okay, this formula not quite as complicated. Only 3 variables, not 4. D distance, R is your speed or your rate, T is your time. Now, let's take a look at this bottom formula, the distance. What letter is by itself in that formula? Brett? D. So we would say this formula is solved for D. Okay. How about the simple interest? What letter is by itself there? Josh? I. So this formula is solved for I. And how about the top formula? What letter is already by itself there? Liam? C. So we'd say this formula is solved for C. What we're going to do is we're going to take one of these formulas and we're going to rearrange it and solve it for a different letter. Okay? And that's actually that's our next example. Okay? We're going to take the temperature formula and solve it for F. So you want to do maybe 5 and 6, Mr. Roy? And I'll do 4. All right. So right now, you've got a formula that can take Fahrenheit and change it into Celsius. We're going to rearrange it so that we're going to have a formula that'll take Celsius and turn it into Fahrenheit. Okay? That might be helpful if you're in another country and they say it's 20 degrees out. Well, what would that be in Fahrenheit? That's what we're used to. Okay? And you'll see on the next problem, we'll do something with it. All right, so let's just write down our formula. And my goal is to get this by itself. Now there's a couple different ways you can do this. Okay, there's a couple different ways. I think probably the best thing is to stick with the order that we're used to. I'm not saying this is going to be the shortest way. I can think of a faster way. But it's probably going to be confusing because it's not the way we've been doing it. So let's stick with that. Okay, so what's in SAM? Does anybody see something we can do under the S step? Simplify. Do we have like terms? Or do we have a distributive property we could do? Vanessa? Yeah, we have a distributive property. So why don't we do that? Okay, that's step 1. Is that going to affect anything on the left right now? No. Okay. Can I do anything like when I have 5/9 times F? Can I combine 5/9 and F together? No, I can't really do anything with it. So just pretty much write what I just said. 5/9 times F minus. Okay. What's the next thing I'm going to do? 5/9 times. Yeah, Liam?
Or negative.
Yeah, I put the negative there, but yep, 5/9 times 32. Okay, any question on that step? All right, so I think what I want to do at this point is let's multiply 5/9 times 32. Okay, just so we don't have to keep looking at that. So on my calculator, I'm going to type 5/9 times 32. Okay, and I get, you know what, let's leave it, let's round it off. 17.78. Okay, let's just round it off. So minus 17.78. All right, so I've done my simplify. Does anybody see any adding or subtracting I could do on both sides?
Think about what you're trying to get by itself.
Well, Kyle, do you see anything? Anything I could add or subtract from both sides that would start to get this by itself? Careful, that's multiplication, right? So we're going to have to handle that when we get to multiplication or division. What would you do if you had something like this? Let's say, I'll just write it without a fraction for now. Yeah, you'd minus the 2, right? So in this case, I don't have quite nice of a number. And what are you going to do to move it to the other side since it's a negative? Yeah, we're going to add it. So just add 17.78 to both sides. Now, can I combine a number and a letter? What do we think? Brett? Nope. So just leave it as C plus 17.78 equals 5/9 F. So now there's only one thing I have to get rid of. 5/9. Anybody remember that trick when you have a fraction? What you do to get rid of it?
That means 5 divided by 9.
Begins with an R. Liam?
Reduce?
If we could, I'd like to, but we can't reduce it.
Oh,
I'll give you a hint. Times.
oh, me?
Sure.
It's still on me?
If you want it to be, sure.
Sorry, I thought somebody else was answering. Reciprocal?
Yeah, you're going to multiply by the reciprocal, and that's going to get exactly what we want. Okay, what's the reciprocal of 5/9? Right, Sabrina? Yeah, 9/5. 9/5. And you multiply by the reciprocal, cancels that out. Okay, and notice I put parentheses around what's on this side. Because when you multiply both sides by something, or like Shannon told us earlier, when you divide, you have to do it everywhere. Multiplying and dividing, you've got to do it to every single thing. So this and that. Well, the first one's easy. 9/5 times C. Well, can't really do anything with that. Now the second one, I'll use my calculator. 9/5. Let's see. 9/5 times 17.78. Okay, I've got a formula that can convert. Bless you. Okay, so it is a little tricky, okay, to do that, but we'll practice more tomorrow, and Mr. Roy is going to show you on example 5 where we use that formula.
Now, we have the formula all set to go. Right here, the 9/5 C plus 32 equals F. My mistake, you want to make that full page for me? There we go. So if you scroll down a little bit, there it is. All right, I'm gonna move it up a little bit so we can see. There we go. There we go. All right. So, it says, which planet has the greatest surface temperature? For which one of these planets are we not going to have to do any work for? Mercury or Venus? Liam?
Venus?
Venus, why?
Because we already have the fair.
Yeah, it's already in Fahrenheit. I know you can't see that, but it's already in Fahrenheit. That's what we want. We don't have to change it. Now, we're going to go back, and we talked about this the first week, evaluate Someone tell me what evaluate means by raising their hand. What's evaluate mean? Josh.
Looking at the number for a variable.
Plug in a number for a variable. All right. So in this particular problem, what letter should we be plugging in for? What do you think, Sai? What letter should we be plugging in for? Because we want to find out mercury, but mercury's in Celsius. We want to put it in Fahrenheit. How are we going to do that? I just want to see where you're at, see if you know. Make sure you're paying attention.
427 would be Celsius.
Perfect. Very good. So, do you agree? I'm going to start with 9/5, then do what?
Right, 400.
What can I do with that to show multiplication? I could put a dot, or I could, what else shows multiplication? Look at parentheses, right?
Yeah.
So 427 plus 32, and that will give us our Fahrenheit. So Mr. Hager's going to get his calculator. He's going to do 9/5 times 427. He's going to get 768.6. Plus 32 equals F. Mr. Hager's going to get his calculator again, and he's going to do 768.6 times 32. Plus, I'm sorry. We're going to get 800.6. That's going to be my Fahrenheit. Now, I'm missing one little thing with that. I'm missing my unit of measurement, right? Centimeters, meters. What are we dealing with here, Shannon?
Fahrenheit.
Dealing with Fahrenheit, but what do we need to put with this number?
Degrees.
Bay? We're going to say degrees, Bay? Yep, little degree thing. So that's how I convert it. So I think the harder part is having to get the F by itself so we can solve, right? To get it plugged in. We do that, like Sai told us, we're just taking the Celsius, plugging it in for C, and then we can solve. Again, you have on all your calculators that little ABC button. You can use that, right, for a fraction. Very simple. All right? So that's number 5. Everybody have that down? All right, because tonight in the homework, we're going to ask you to do the same kind of thing. Solve the formula we give you for another letter. Once you do that, take it, and we're going to give you something, and you have to plug it in for that. All right?
So what's the answer? We haven't answered the question yet.
Oh. So which planet? We got Mercury with 800.6 degrees Fahrenheit. We got Venus with 864 degrees Fahrenheit. Which one has the greatest surface temperature?
Venus.
Venus does. So I'm going to write up here. All right, Venus has the greatest, like Emily told us, Venus has the greatest surface temperature. Good? Yes? Last one. All right, so you deposit $500 in an account that earns simple interest. After half a year, the account earns $162.50 in interest. What is the annual interest rate? So, Mr. Hager's going to, Mr. Hager's going to put it up there for you guys anyways. That's the formula we're going to use. Even if we didn't know that, all right, we start dealing with anytime we're depositing money, anything like that, we're dealing with interest. We're dealing with this I equals principal times rate times time. All right, so which out of these 4 letters that we have, the I, the P, the R, the T, which one is going to remain a letter? Which one's going to remain a letter? Just based on what's in the problem. Which one's going to stay as a letter? Who said it? I, right? Because it asks, what is the annual interest right? I don't know why I didn't circle, but what's the annual interest? So it'll be,
So rates are,
oh,
because we're finding the rate.
oh, the rate, I'm sorry. Interest rate, my bad. And then I didn't read the bottom. So what is the annual interest rate? So the R is going to stay as R. Everything else is going to stay, everything else is going to become a number. All right? So what am I going to put for I? Someone tell me, what am I going to put for I? Kyle.
$162.
$162.50. Tells us right there. There it is, in interest. Equals my principal. I'll give you a hint. Principal is how much you put in. What's that principal going to be? Shannon. $5,000. Next thing should be what? Before that. We're leaving it at that. That's what we're trying to find, the rate. R. One more thing. The time. What's the time? So what should I put instead of T? Kaylee, what am I going to put? 0.5? I can even use I can use a half, but again, it might be better to put 0.5 because sometimes decimals are a little bit easier to work with. You guys get afraid of fractions sometimes, and I do too. All right? So that's what we got. Now, Mr. Hager's going to put parentheses around this. What can I do on the right-hand side of that equal sign? Someone tell me. What can I do on that right-hand side of the equal sign? Ashley, what do you think? What can I do?
Can you divide?
Not divide, not yet. We gotta do one thing before we can divide. Look at those parentheses I have up there. Anybody think they know?
Have everyone's attention.
All right, what I'm going to do, guys, is 5,000 times 0.5. That's what I'm going to do. So Mr. Hager's going to get his calculator up for me.
2,500.
Huh?
2,500.
2,500, didn't even need it. Basically, it's saying what's half of 5,000. So 2,500 R equals. All right, now to my last step. Someone tell me what I'm going to do. Even though the number's bigger, we've done this, even though the number's a little bit bigger, we've done this before. What do I need to do? Someone tell me by raising their hand. Ariel. Excellent. 2,500. 2,500. Mr. Hager's going to get it up on the calculator for me. Remember, number on the top always goes in first. So, if I'm dealing with, remember, I got 0.065 equals my interest rate. All right. Remember, interest rate is always in what form? Huh? Decimal, but it's going to be in percent form, right? 3% interest, 4% interest. What would that be as a percent? I want to move this decimal twice to the right, so my rate would be what? 6.5%. All right? So, we'll let them go one time. I'm going to give you tonight's homework. You've got 4 problems where you have to get y by itself. Number 5 is just like we did, where you have to, the one we just did, you're going to find either the interest, the rate, the time, something like that. And then 6 has 2 parts. We're going to change the formula to solve for another letter. Then we're going to solve for that letter. And then the last 2, 7 and 8, are review from stuff we did on Monday and Tuesday. I don't know. I was just trying to find something else kind of what we did today.